Hello and welcome to this screencast on matrix addition, subtraction and multiplication by a scalar. So I'm going to start off by talking about matrix addition, and the definition of matrix addition of matrix A plus matrix B, is equal to the element plus the elements of B. So I'm just going to explain this definition I've written down. Okay, so on the left hand side we have two matrices A and B, and I'm using this subscript notation, so where I denotes the ith row and J denotes the jth column. So this notation means the ith jth element of A plus B, of the matrices A plus B. Okay, and that's equal to the ith jth element of A plus the ith jth element of B. Okay, so all that means is if we want to add two matrices A plus B, we simply add the corresponding elements. Okay, so if I do a quick example, so I'm going to write down two 2x2 matrices, and I'm going to add them together. Okay, I just made these matrices up. Okay, so the element in the first row, first column is simply the sum of the corresponding elements in the first row, first column. So in this case, I have 1 plus 1. For the first row, second column, I'll have 2 plus 3. Second row this time and first column, I've got 3 plus 0. And finally, second row, second column, I've got 4 minus 4. Because remember, when you add a negative number, it's the same as subtracting a number. So if I just evaluate the sums, I have 2, 5, 3, and 0. And that's the addition of those 2x2 matrices. Okay, one thing you have got to be aware of with matrix addition and subtraction is the fact that two matrices have to be of the same dimensions. They have to have the same number of rows and columns. Okay, and now we're going to have a look at matrix subtraction. Oh, can't spell. Subtraction. Okay, and matrix subtraction is defined very, very similarly, except as to matrix addition, except for this time we've got a subtraction symbol. Okay, so basically it means instead of adding the corresponding elements, in this case we subtract them. So using the same two matrices as before, so I'm going to use two 2x2 matrices, this time I'm just going to subtract the elements. Okay, so same thing as before. In the first row, first column, I have 1 and 1, so we've got 1 minus 1. First row, second column is 2 minus 3. 3 minus 1 in the second row, first column. And in the second column, second row, I have 4 minus minus 4. So 4 minus minus 4 is indeed 4 plus 4. Okay. Right, so if I evaluate all of those, remember dealing with negative numbers, and I get 0, minus 1, 3, and 8. Okay, the last thing I'm going to look at is matrix multiplication by a scalar. There are two types of matrix multiplication. This is the easier one. I'll explain the other one on another podcast by a scalar. So remember, a scalar is simply a value, a single number. So if we have a matrix A which is multiplied by a number k, okay, the ith element is simply the scalar k, or the number, multiplied by each element in A. So for example, if I have 3 multiplied by my first matrix above, this is the same as saying every element in the matrix is multiplied by the scalar 3. Okay. 4 times 3 is the last one. Okay, so if we evaluate those products, we've got 3, 6, 9, and 12. Okay, so that's matrix multiplication by a scalar. It should not be confused with matrix multiplication, which I'll have a look at on a different podcast.